support our coverage with a free account on Privacy, the service that keeps you protected when shopping online. Get $5 to try it now by using promo code QZZ2J.
But we have our next guest here. Hello.
Hello.
How are you doing today?
Doing great. Really excited to be in Las Vegas.
Yes.
This is our second CES,
Okay.
so really great experience.
Fantastic. So go ahead and introduce yourself and let us know about what we're looking at here.
Okay. So I'm Steve Gussenhoven. I'm the Marketing Communications Manager for a small French startup called IoTize. We're based near the French Alps. And we come from a group of people who were originally suppliers of tools for embedded systems design.
Okay.
And a few years ago, we were getting lots of questions from our kind of historic customers about, well, what is your company going to be doing for us to help us create IoT-connected designs? And we actually realized that we had some technology coming from embedded systems design that would allow us to expedite the design process, remove the need for a lot of extensive coding, and we'll see here, I think, with the demonstration where that's kind of taken us. It's become quite a complete ecosystem that we call a no-code IoT solution.
Okay. So we've got a lot of things here in front of us. I'm guessing that this is the core.
You're exactly right. This is the core to what we did. This is actually probably about our third design. Here, I'll let you take a look. It's originally the design was based on our in-circuit debugger programmer.
Okay.
And that allows us to exploit some resources on microcontrollers that allow us to plug directly into a microcontroller and recuperate data and bring that data to the outside world.
Okay.
And without changing the code on original design. And that's where this robot comes up.
Okay.
Essentially, the robot was something our designers purchased off the shelf.
Okay.
And they just said, hey, this will be a fun project, and it looks good, it shows. And essentially what they did was, it's a demonstration case of what we do with the module, is they've actually placed the module here and plugged it into the processor.
All right.
And to implement that module with this processor, all they had to do was configure the module with the addresses where the data resides that we want to read or write in order to know what the robot is doing in order to control it. So there's zero coding to do in order to do this. And then as a complement to what we do, so all that's based on our firmware in the module.
Okay.
And as a complement to that, we also provide a simple configuration environment, no-code environment as well too, and an environment that allows us to create an off-boarded human-machine interface that can run as a mobile app. And that's what I actually have right here.
Okay.
I'll just go ahead and start it up here so we can see
That
how
might be upside down.
Yeah, I think there we go. And so essentially, I'll just start her here real quick. I have to connect just a second. I'm not sure if people can actually see that.
That camera right there.
Okay, and so what that's doing is actually, that's our mobile app that's connecting to the module, and it's drawn up a dashboard that has the different controls that we have available. We can go ahead and start the robot. There we go. And it's a small area here, but
it is.
There we go. Okay. And so this interface is actually created simply using our mobile app and the configuration of the module. And that mobile app allows us to, for the different variables that we have identified for the module, to associate them with buttons, for example, to turn left, to turn right, to move forward or backwards. And those are all variables within the original system that we defined as being writable.
Okay.
In addition to that, we also have a section that's the different settings, there are different sensitivities, as well as a screen that allows us to monitor the different, what's happening with the robot. For example, there's a radar at the front of it. We'll see that as I approach, you'll see the distance to obstacle changes there. And so that's simply the variable that's associated with that radar feature.
Okay.
So I see a puzzled question. Yeah.
Okay. So, couple things. So let's start here. I am guessing that all of our little gold connectors here are I/O connectors?
Yes, exactly.
Okay. So anybody who's familiar with an Arduino or using something like that,
Yep.
be familiar with I/O.
Yep.
So this would be the same general concept.
Yes.
So this is connecting to the board of a predefined, this thing is not yours, you didn't build it, we know nothing about it going into it. In theory,
Yeah.
we went and bought it off the shelf.
Right.
We want to integrate this into it.
Yep.
So we've taken the I/O and connected it to the board
Okay.
in some way, shape, or form.
Okay, not quite. We
Okay.
haven't connected the I/O. In this case, we started off, the I/O are there for a purpose. In this case, what we did was we connected, for the simplest connection, we connected our module to the debugging port of the microcontroller in the robot. And that debugging port gives us full access to all the memory. Now, there's another method to connect as well, too. When you go to a final product, you're not going to leave a debugging port open. So we use those same 2 pins that are reserved for the debugging port typically, and there's a little bit of code in that case that we actually generate for the user. He relinks his application, but that creates a secured access that's based on the configuration of the module.
Okay.
So in this case, we're using the debug port.
Okay.
Now, to go back to the I/O, one of the things we do add, because the idea was to be no code and configuration only. But at the same time, you have to reserve some liberty for people who do something special.
Sure.
And we all do something special. So that specialness, that extra mile that you can get out of these devices is the I/O that we provide
Okay.
and a Java virtual machine.
Oh.
So inside the module, you have a Java virtual machine, and if you want to, for example, connect another external sensor, temperature sensor, we'll just say for the fun of it.
Sure.
You want to connect another temperature sensor, you can code in Java, include that in the configuration,
Okay.
and simply communicate with that temperature sensor over SPI or accelerometer or whatever it is you may want to add into the design.
Okay.
So there's always some flexibility like that in what we do, but the fundamentals are to try to be no code, plug and play, configuration only.
Sure. To be no code versus zero code.
Exactly.
Because with zero code, we couldn't go beyond.
Right.
But this is a no code solution. We can get there in theory,
Exactly.
but we can get further if we add a little bit more.
If we go beyond.
I understand.
Exactly.
Okay.
And so at the same time, so we have that flexibility in the embedded software,
Okay.
Java virtual machine. But then at the same time, we also provide an environment we call IoT App Creator that we're just introducing now
Okay.
that allows you to, instead of using the mobile app here that we use to create that, we have an environment, it's based on the same mobile app. We have an environment that runs on your PC, and it gives you a drag and drop interface for associating variables with buttons and sliders and graphs and things like
Okay.
that. The same thing, if you don't want to go any further than that, you can do the simple drag and drop. That's this gauge is associated with the temperature. Okay, very simple. There's another level behind that, though, data flow editor, and that data flow editor allows us to, with some simple logic nodes, combine data or combine variables in ways so that we can have more complex parameters, or to apply conversions. I always love to say that. We come from Europe. We think in Celsius.
Sure.
A simple conversion puts us into Fahrenheit, and that can be done in that data node editor. As well as there are some nodes that are reserved for adding a little Java code to do what other special things you might want to do.
Okay.
That environment, that HMI environment, is associated with some an app builder based on the Ionic tool set. When you're satisfied with your user interface, you click on a button, it goes to our app builder. You can generate apps for iOS, for Android, or web apps that can run on a PC in a browser, or that could also be, for example, your cloud dashboard.
Yeah.
If you wanted to start bringing data to the cloud.
Okay.
So, and as we said, there's always code.
Right, of course.
For a no-code person, they don't have to look at it if they don't want to. But
Click, 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 done.
off it goes. But that app builder generates a complete project, and therein you have all the code. And so if somebody wants to go and work further with that, they can continue to work with that code.
So it runs native? It creates native code?
Yes. Yeah,
Fantastic.
exactly.
Thank goodness.
and so that's where that was one of the keys to this whole thing, was to have the flexibility of web apps that turn anywhere, but also the functionality of native apps that you can publish and
speed
you can do more
and
with.
all the things that,
exactly
that like a web-based mobile app just doesn't have.
Absolutely.
We can ask Facebook how that went.
Yeah, exactly. So to not create any confusion, we don't do the robot. It was an off-the-shelf. This is a demonstration of how easy it can actually be, and quite literally, it took longer to deliver the robot than it did to create the user interface and the implementation. But where we're seeing a lot of interest in this no-code approach is these same modules are used in industrial devices like this that support a lot of common industrial field buses and that allow us to retrofit infrastructure to be IoT, IIoT, or Industry 4.0 compatible.
100% is what I was seeing.
Yeah.
Being able to retrofit older non-connected devices into being connected devices.
Exactly.
Yeah,
exactly.
That's fantastic. So where in the process are we? Is this on market today?
Yes. So in fact, the modules like this are available. In fact, these are available. Your listeners here in the United States will find them on Mouser and DigiKey. It's the Tap and Link under Tap and Link Primer, so you can give it a try. And these industrial modules have been on the market for about a year now. A complete series that cover a wide range of industrial protocols from RS-232, 485, Ethernet, CAN for people who are kind of in the automotive or in certain industrial applications. And there's a new line of products that we just started sampling at the end of 2023 called Tap Bus, which are programmable input-output devices for industry.
Okay.
So yeah, complete line of products and going increasingly towards industrial as well too.
Gotcha.
Yeah.
What kind of price point are we talking about on that little board?
So on this little board, so to buy the development kit, it runs at $49, I believe. Okay. And for small volumes of this device, I believe we're around $15 a piece. Okay. So. Nice.
If people want more information about your platform and everything, how can they get it?
It's really easy to find. Go to IoTize.com, so IoTize.com. They'll find all the product lines and all the recently released software and everything there.
Fantastic.
Okay.
I appreciate you coming and talking to me today. This is really cool.
Excellent. Well, thank you very much.
Absolutely. Have a good rest of the show.
Thank you. Bye-bye.
The Tech Podcast Network CES 2024 coverage is executive produced by Michelle Mendez. Technical directors are Kurt Corliss and Adam Barker. Associate producers are Nancy Ertz, Clinton Millsap, Sergio Velasquez, and Terry Willingham. Voiceover by Aaron Hurst. Our hosts are Marlo Anderson, Don Bain, Todd Cochran, Scott Ertz, and Christopher Jordan. Studio and equipment are provided by PLUGHITZ Productions. This has been a Tech Podcast Network broadcast, copyright 2024.